Hello. This is an introduction video for the textbook, Numerical Methods for Scientists and Engineers, with Pseudocodes. This book is intended primarily as a core textbook for courses taught under the general title of Numerical Methods. It can also be used as a supplementary textbook for upper-level or advanced undergraduate or graduate courses, as well as a reference book for practicing engineers.
Objective of the book.
The objective of the text can be summarized as follows. Provide a strong theoretical background on numerical methods encountered in science and engineering education and beyond. Understand and implement the methods to practical problems. Develop the ability to choose a suitable method for a given problem, with its advantages and disadvantages in mind. Gain the skill of converting numerical algorithms into running computer codes, emphasized via pseudocodes.
Learning objectives.
Each chapter begins with the learning objectives, which briefly describe educational goals and competencies to be achieved. The theoretical and applied objectives make up the broader aims of the course. The learning objectives inform the students what they should master by the end of each chapter.
Content of the book.
The content of the book is designed for a one-semester course. It consists of 11 chapters covering the fundamental methods as well as some advanced topics with significant reference values. In the arrangement of the chapters, the contents of the subsequent chapters have been taken into account so that a student new to a subject can digest the course material chapter by chapter. In cases where there is little interdependence between the chapters, a sufficiently brief introduction to the pertinent topic is provided before it is covered in greater detail in the following chapters. The science and engineering students want to see the relevance of the course in their professional education. Accordingly, in each chapter, the importance and application areas of the topics in science and engineering are briefly stated. Every method is kept as simple as possible, and proofs have only been included where they help students understand the underlying theory of the method better. Immediately after a method is presented, its application is reinforced with example problems that comprehensively and thoroughly illustrate and explain the complexities and potential difficulties of the method. Most exercise as well as solved problems consist of problems with known exact solutions, allowing a clear and concise assessment of the performance of the method. There are a total of 108 solved example problems, in which the solution is explained step by step and through error assessments. There are a total of 96 pseudocodes as modules, and numerous attention boxes. Advantages and disadvantages of methods covered are presented with pros and cons boxes. There are 225 high-quality images. The science and engineering students are motivated by solved examples and end-of-chapter exercises. Furthermore, solved examples and end-of-chapter exercise problems are also selected from various disciplines to demonstrate the relevance of the methods in science and engineering. In addition to exercise problems, each chapter includes computer assignments. There are a total of 115 computer assignments. Some exercise problems are also suitable to be assigned as computer projects. Each chapter ends with a closure section that provides a concise recap of the key features of the numerical methods, reinforcing learning and helping students retain information. The closures also serve as a bridge to the next chapter, helping students see the continuity in their learning journey.
Attention boxes.
To grab the attention of students, key points, good practices, pitfalls, or warnings in connection with the application of a numerical method are highlighted throughout the text using the attention boxes.
Pros and cons boxes.
Numerical methods devised for a specific mathematical problem differ from each other in objective, scope, degree of accuracy, amount of computation, and so on. In this regard, no single numerical method is suitable for handling every problem in its class. Consequently, there are usually several methods to solve a given problem numerically. For this reason, in the theoretical part, the basics of a numerical method and associated errors are presented, and a clear and concise idea of when the method performs well or poorly is provided as well. This kind of knowledge is critical and necessary, even if one uses modules or procedures from available software packages. As a result, the ability to select a suitable method for a numerical task is crucial for the accurate and successful implementation of any numerical method. In this context, after a numerical method is presented, its advantages and disadvantages are presented with pros and cons box. Pros and cons box help students make well-informed choices based on their specific needs and circumstances, leading to informed decision-making. Pros and cons boxes also foster critical thinking skills, allowing students to evaluate the effectiveness of different methods. Highlighting the disadvantages helps students identify potential pitfalls and challenges, preparing them for possible obstacles. It can lead to tailored implementations. By understanding both pros and cons allows students to adapt methods to better fit their unique situations. A comprehensive overview promotes deeper comprehension of a method, including its context and limitations. And finally, this style provides a clear view of strengths and weaknesses, empowers students to take ownership of their choices and outcomes. With this approach, by the end of the course, the students are expected to have gained the ability to question and understand the purpose and limitations of the methods or modules before using them.
Why use pseudocodes?
The text contains a total of 96 pseudocodes. Every numerical algorithm is presented as a completely independent pseudomodule that can be converted and used with other programs. Some pseudocodes use one or more of the pseudomodules presented in prior sections or chapters. Currently, there is not a common standard for writing pseudocodes. With minor changes, this textbook adopts the pseudocode convention from Terence Akai's textbook Applied Numerical Methods for Engineers, which has been observed through experience, in classroom, to be effective for teaching algorithm and programming to beginner and pre-intermediate level students. Most algorithms covered in the text are presented as self-contained pseudomodules that can be converted into any programming language and used with any program. Why use pseudocodes? Today's engineers and scientists are expected to become proficient in one or more programming languages as well as a number of software packages such as MATLAB, Mathematica, Maple, etc. To be more general and inclusive, the text is not tied to any specific programming language or to any specific symbolic software package. This approach aims to teach numerical methods that students will encounter in their future courses or careers while enabling them to gain the ability to prepare and/or use well-structured programs in a variety of languages. Also, a majority of problems that scientists and engineers face today cannot be tackled by employing a single method or single module. At some point, programming proficiency is required to implement a series of numerical methods within a broader computer program to achieve a more global computational objective. In this respect, the best way to learn numerical methods is to reinforce the application skills with computer programming while taking the Numerical Methods course. Other benefits of using the pseudocodes are: they allow students to focus on the logic and structure of algorithms without getting bogged down by programming language specifics. They are versatile for teaching concepts that can be applied in different languages. They act as a perfect bridge between algorithm design and real coding, making it easy for students to convert pseudocode into code. They help students grasp complex algorithms better, as they can write out the steps in a more readable format. They promote good programming practices, such as breaking down problems into manageable steps and thinking algorithmically. The basic structured programming statements and commands of common programming languages are adopted in this pseudocode convention, which is presented in the appendix section. Additionally, a 3-part video series has been prepared and uploaded on YouTube. These videos can be accessed from the links provided on the supporting GitHub site. The modules are written as simply as possible, with very few commands, so that translation to other programming platforms is as easy as possible. The pseudocodes adopted in the text mimic the full features of a real program, with a program or module name, parameter lists, and so on. A brief description for each pseudocode is provided in the header section. Following the uses statement in the description, the program dependencies, that is, required built-in or user-defined functions and subroutines, are specified. Wherever possible, line-by-line annotations are used to leave no question as to what is done. This approach blends the methods and algorithms with sufficient mathematical theory and supports easy understanding and implementation of the algorithms.
End of chapter exercise problems.
The book includes more than 1,500 end-of-chapter exercise problems presented at the end of each chapter, organized according to sections. These problems emphasize the mechanics of the method and are designed to give practice in applying the algorithms presented. The majority of the exercises are made up of problems having exact or true solutions, allowing for an accurate quantitative performance assessment of the methods. Some problems that are purely mathematical in nature are designed not only to reinforce methods through practice but also to demonstrate the strengths and weaknesses of a method. Additional applied or realistic problems are chosen from various fields of science and engineering to help reinforce understanding of methods and demonstrate their relevance in applied problems.
End of chapter computer assignments.
It is important that students can select and use the most suitable modules, methods, for their applications from existing software, and also be able to program numerical algorithms in a language required by the course or in a language of their own choice. To develop programming and parametric analysis skills, a total of 115 problems are provided as computer assignments at the end of each chapter, which require using and/or writing and running computer code of the instructor's choice and analyzing the results. The instructors may use or modify some exercises or computer assignment problems to allow methodological analysis and comparisons. By the end of the course, the student should realize and appreciate the importance of this skill in his profession.
An accompanying website.
A website has been created for the courses that follow the textbook. This e-learning platform was created to provide as supplementary material to the textbook, additional context, or explanations for both lecturers and students to benefit from. Students can access these supplementary materials anytime and anywhere, allowing them to learn at their own pace and revisit challenging topics as needed. This website caters to different learning preferences, combining auditory and visual elements. The website is organized into chapters. Each chapter contains C, C++, Python, Visual Basic and VBA, Fortran 95, MATLAB, and Mathematica modules converted using some pseudocode presented in the textbook. These programs illustrate how a pseudocode can be converted to an actual code. Engaging students with the codes helps them develop essential programming skills, including debugging, problem-solving, and logical thinking. Running programs provide students with immediate feedback, which enhances learning. Students can experiment with codes by running programs, which allows them to get immediate feedback and deeper understanding as they troubleshoot and modify programs and implement methods. Incorporating several computer programming languages in this platform enriches the learning experience, making it more interactive and relevant to today's technological landscape. Comprehension questions are provided to help evaluate whether a student has grasped the theory, implementation, and programming ideas, and advantages or disadvantages of a method. These questions often require students to analyze, interpret, and make connections, fostering deeper engagement with the material. Answering questions can reinforce memory, helping students retain the information they have read. Videos capture students' attention more effectively than text alone, making the material more interesting and easier to absorb. Videos incorporating animations or demonstrations help visualize and explain complex concepts. That is why some educational videos have been prepared and uploaded to YouTube. The links to videos are presented chapter by chapter. The site will also include quizzes on certain topics. The site will be dynamic. New materials as required will be supplied.
Resources for instructors.
As for the instructors, lecture presentations in PowerPoint will be made available free of charge at the Instructor Resources Download Hub. In total, there are 1,066 slides. These presentations have been prepared in two-color, and they summarize the theory and illustrate the pseudocodes. A 1,300-page Instructor Solutions Manual is also available free of charge to the instructors at the Instructor Resources Download Hub. This manual contains the solutions for all exercise problems and solutions of some of the computer assignments.
To order your copy, visit the website www.routledge.com. Goodbye.